Hey everybody, I just wanted to talk through a little bit in class today. We took some notes on ratios and rates. So we talked about calculating out the ratio of the different smiley faces, the answers that are in the box using the colon are in simplified form. So make sure that you show your work and that you need to show 3 different ways to show the ratio. You're going to show it as a fraction, you're going to show it using a colon, and then you're also going to show it using the words. All right. So one of the things that we did not get to spend a whole lot of time was talking about this problem on the back side. So I know that you can't see this right now based upon my screen, but you will have your own copy of this in the assignment. So what we're going to do is we're actually just going to work through the problems here on the whiteboard. All right, so let's take a look at this. So in our problem, it says, a small university enrolls in-state and out-of-state students. The number of students enrolled in their most recent freshman class was 243. The school reported that it enrolled 7 in-state students for every 2 out-of-state students. How many of each type of student was enrolled in the freshman class? Okay, things that we know. We know that the total students of the whole freshman class was 243. We know for every 7 in-state students, there are 2 out-of-state students. So we could write a ratio of in-state to out-of-state. But I also want you to know that those students together create a group of 9 students. All right. And we want to know how many of each type of student there are. We want to know how many in-state students, and we want to know how many out-of-state students. So in our notes, we found out that there are 2 ways that we can solve proportions. The first is scaling. The second is cross multiplying. The most common way is to cross multiply. So I want to share that with you first. All right. So if I'm going to cross multiply in your notes, if you remember, it said that I'm going to take the numerator from the first fraction and multiply it by the denominator of the second fraction. So that means I'm going to take 7 and I'm going to multiply times 243. All right, so 7 times 243 equals, and then I'm going to have the other side, the other numerator times the other denominator. So on the right side of my equation, I'm going to have 9x. All right, last year you did some work with single variable equations. So that's what we're going to do today. So remember I told you that you can use your calculator. So you can use a cell phone, you can use any calculator that you want. So I'm going to multiply 7 times 243, and that is equal to 1,701 is going to equal 9x. And when I'm solving for equations, I am trying to get the variable all by its little lonesome, right? So 9x means 9 times x. So what I need to do is I need to do the opposite of times, which is to divide. So I divide this side by 9. Because anytime a numerator and a denominator are the same, that's the same as 1 whole. And I also need to divide the left side. Whatever I'm doing when I'm balancing equations, it's like a teeter-totter. Whatever I do to one side, I need to do to the other side. All right, so I have 1,701 divided by 9. And when I put that into my calculator, it is 189 equals X. Okay, so what does X represent? Well, the green X right here is representing my in-state students. So 189 students out of 243 students are in-state students. Right now I have to find the out-of-state students. So I'm going to follow the same procedure with my out-of-state students, still using cross multiplication. So I take the numerator here, multiply by the denominator there. So this time I have 2 times 243. And that is going to equal this numerator times this denominator, which is 9x. Okay, the 9 stays the same because the denominators were the same and they are part of that entire whole group. So now I have 2 times 243, which happens to be 486, is going to equal 9x. I need to get x all by its little lonesome. So this pink number 9 is called a coefficient. So what I need to do is do the opposite. All right, so the opposite of multiplying by 9 is dividing by 9. And whatever I do to one side, it's like a teeter-totter. I need to divide the other side by 9. Given that a numerator and a denominator that are the same is equal to 1 whole. So I'm left with x on this side, and now I need 486 divided by 9. So I can use my calculator. And 486 divided by 9 is 54. All right, so that means that 54 students out of 243 students are out of state students. Okay, so this is one answer. This is another answer. So this is the most common way to solve proportions. But we can also use the scaling method. And the scaling method is similar to what we did when we were working with unit rates. And the fact that we want to divide the numerator and the denominator by the same number to get a smaller simplified fraction. So the scaling goes both ways. This, from a smaller fraction to a larger equivalent fraction, I'm multiplying by the same number in the numerator and the denominator. And when I'm going this direction from a larger to a smaller, I'm dividing. So I can look and see what is 243 divided by some number is 9. Okay, 243 divided by some number is 9. Well, I also know that due to the commutative property, I can change the order. 243 divided by 9 is 27. So 243 divided by 27 is 9. If I'm trying to find this number over here using the scaling method, I'm going to multiply by 27 because I'm going to the bigger number. So 7 times 27 is going to give me the number of students. And if I did it right, I will come up with the same number. So 7 times 27, 7 times 27 equals X. X equals 189. Okay? So I'm still going to have 189 out of 243 students are in-state students, right? Using that same method for our out-of-state students, 243 divided by some number, because we're moving to a smaller value and moving to the left, 243 divided by some number equals 9. And we found out up here that that number that we divide by is 27. So I can divide, I want green. If I divide by 27 when I'm going this direction, I'm going to multiply by 27 because I'm going the other direction and going to a larger value. So now I have 2 times 27. So 2 times, we don't want to use that X, we want to use the dot. 2 times 27 equals X. 2 times 27 is 54. So again, 54 out of 243 are going to be out-of-state students. Okay, we're going to be working with both types of methods, and you will need to know both of those. So if you are confused, need a little review, go back and watch the video again, and we'll look forward to seeing you in the next class period. Take care.